our next talk on State of SSL on the Internet in 2010, and it's presented by Ristic, Director of Engineering for Web Application Firewalls and SSL at Qualys. Please give a warm welcome to Ivan.
Thank you. So I'm going to talk today about SSL and in particular about our survey of how SSL is currently used on the Internet. What you can see on the screen right now is the agenda. Although it's slightly misleading, I have about 50 slides, which is way too many. So I'm pretty much going to skip through the first half of the talk and leave the slides there for you to use later. And then I'll spend most of my time on the actual survey results, which are really fascinating. There are about 20 slides in the survey, which are packed with information. And we will go through every single of those slides, and I will comment on the results. So just quickly about myself to give you a reason why you should listen to me. I've spent quite a few years working in security right now, by now. And basically what I like to do is pick on a topic that's not really very popular or covered by other people, and then look deep into it and try to figure out. In a way, I do it as a way of educating myself, because there's no better way to learn about the technology than to go deep and learn everything there is about it. So this is how I came to work on SSL. Like a year and a half ago, or 2 years ago, I wanted to revisit the topic, and I realized that actually there is so little written, so little information about SSL out there for people who are not necessarily interested in the protocol itself, but in using it. And one thing led to another. So what eventually happened is that we started this research effort, which we called SSL Labs, which is just a website, a non-commercial effort where we try to make sense of SSL. So the survey that I'll be talking today is about that and making sense about SSL. So if you go to the SSL Labs website, you will find that we have a number of interesting projects. For example, on the screen you can see the SSL fail model, which is very helpful if you want to understand in which ways SSL can fail. And there are other projects. Most interesting one is the SSL Rating guide. One of the first things I realized when starting to look into SSL is it's very difficult actually for normal people who are not SSL expert, to understand if a particular server is configured well or not. So this is how the SSL Rating guide was born. And the idea was to have a decent methodology that will basically sum up a configuration of a particular SSL server into a grade. And as you will see later on, the good thing about doing this is that if you give people a single grade, which is a letter from A to F, it's very easy for them to understand if they're doing things well, even if they don't know much about SSL itself. Now, the guide is not an attempt to kind of come up with a perfectly accurate grade, but its main purpose is just to convey a meaning and allow us to compare the configuration of different SSL servers and point and say which server is better configured. Also, what the rating guide does not cover is it doesn't look into the cost, interoperability issues, or performance issues of SSL, which sort of would make it into a much larger project. So the thing about the SSL Rating guide, we basically use it as a foundation for our assessment engine. And I think this is the best part about the SSL Labs website, which is a free assessment tool where you can go to the website, you can type in the domain name of your SSL server, and then the tool will actually go inspect your SSL configuration and tell you everything that you need to know about it. So I have some partial screenshots for you here. So you can see that the goal of this assessment tool is to give you the grade. So at a glance, you can find out what's going on. And then also, you will be given full details of every single aspect of the SSL configuration. I imagine we have about 200 data points that we collect from every SSL server. And the test itself is quite comprehensive. So I think there's about 2,000 packets or 200 TCP connections and 250 kilobytes of data that we exchange with every SSL server that we test. Furthermore, we will also look into all the servers that are behind a single domain name, and we will point to inconsistencies in configuration among them. So part of my reason for being here today is that we want to raise, generally speaking, raise awareness about SSL misconfiguration problems, and we want to get as many people as possible to visit our online website and test their own sites. However, we also realized that no one has really looked into how SSL is used worldwide. And then we decided to use the same assessment engine that we have and run it against as many SSL servers as possible. To build the assessment engine is not a trivial task. The one that we have online, we probably spent a year perfecting, because it's one thing looking at reading the documentation and the RFCs and building something from that. It's an entirely another problem actually looking at how things work in real life. So the long period during which the engine was online allowed us to really identify these real-life issues and fix them before we undertake our SSL survey. Anyway, so that's a very quick introduction into SSL Labs. The next section of my presentation is about finding the SSL service to inspect. Of course, the challenge is how do you find this service, because there isn't a single registry of service on the internet. And there are various ways in which you can go about doing this. You can, for example, scan large batches of IPv4 address space. You can crawl the internet. You can build a search engine so you can catch all the links that are out there. You can use domain name registrations and then look at each individual domain name and see if it supports SSL, and so on and so forth. Another approach, for example, is to use a browser toolbar, which will basically catch and see where users are browsing. Generally speaking, neither of these approaches is perfect, and it's probably best to combine all of them in order to get the best possible coverage. Generally speaking, it may not be ever possible to build a complete list of all SSL servers on the internet, because there is sometimes a way to, the mapping is not always one-to-one. For example, a single SSL server, even today when virtual SSL hosting is not possible, can actually serve multiple sites and multiple certificates. So in general, you can never really be sure that you're seeing everything. So for our survey, we decided to go with the domain name registrations simply because that was the quickest and most predictable way in which we could get to a large number of domain names and SSL servers. So what we basically did, we collected the complete lists of .com, .org, .net, .info, .biz, and US domain names, and we got a list about 120 million of those, which, because we know there's about slightly less than 200 million registered domain names worldwide, our coverage is about 57%. And I think we got most, if not almost all, top-level domain names, but in the survey we didn't use any of the country-specific top-level domain names. Also, as an additional data set, we looked at the top 1 million most popular websites, which is a list that is combined and published by Alexa Internet. This other list will give us a much smaller number of SSL servers. However, in a sense, that list is more meaningful because these are sites that people are actually visiting. And because our data set was 120 million, and because our assessment engine takes a long time to assess a server, what we did in the survey, we had a very lightweight first pass. And in that first pass, we wanted to just identify those servers and domain names that are active and that are running SSL. So this section of the talk is actually a sort of a survey within the survey, which will give you some idea of how many domain names there are, and how they're used. So for the lightweight pass, we built a very simple assessment program, which basically uses as few packets as possible, doesn't complete even a single SSL handshake, because we had so many domain names to scan. And we managed to build a single process tool that used 2,000 threads running in parallel that allowed us to achieve a speed of about 1,000 domain names per second, and which was quite a good speed, which allowed us to scan all the 120 million domain names in about a day and a half. This speed can probably be further improved, but for us there wasn't a reason to do that because what we had was fast enough. And here are the results. Basically, almost 1/4 of all domain names didn't even respond, either because there was a problem with the DNS or because there was no server listening on either port 80 or port 443. So that's what left us with about 92 million domain names. And then we continued to drill into these results and narrow down the numbers as we go on further, because our goal for the survey is to find those certificates and SSL servers that are actually used and that people intended to use. So our logic was that if we look at certificates that we get and compare the name in the certificate with the domain name that we are looking at, and if there's a match between these two names, then we found a certificate that we can look into deeper. So we looked into the active domain names. Most of them, almost all of them, responded at port 80, and only about more than a third responded on port 443. But even those that responded port 443 didn't offer SSL. Only 2/3 actually had SSL running, and 1/3 had protocols other than SSL. This is not unusual because port 443 is usually open on firewall, so people use it for. It's very handy because it's always there. Most of these non-SSL servers are just plain text HTTP, although we have found quite a large number of secure shell servers there as well. Anyway, drilling down into the 22 million SSL servers, we just then extracted all the certificate names and then compared the names, and then we found that there's about 720,000 certificates where the names matched. And this is the data sample that's actually very useful to us and that we wanted to keep and use in the second phase of our study. Just as a way of comparing things, the pie chart on the right, donut on the right, is the same analysis of the Alex's top 1 million domain names. So you can see that, relatively speaking, almost 1/4 of all top 1 million websites actually have SSL, proper certificate names that match the domain names, which also makes sense because in our large sample, there are all sorts of domain names, most of which are probably parked. So the survey so far tells us a lot about the state of web hosting and virtual web hosting on the internet. If you look at the numbers, we're looking at 120 million domain names, but they're all represented by only 5 million IP addresses, which on average means that one IP address will host about 20 websites. And if you look only at those sites that support SSL, it's about 1 in 10. There's about 10 SSL sites behind the domain name. So this discrepancy and the large difference in numbers points to two burning problems with SSL. And one is the virtual SSL hosting is not possible. Virtual hosting is possible, and you can put as many websites on a single IP address. And this feature is what caused the explosion of popularity of the web. And it's very unfortunate we don't have the same feature for SSL. So today, to deploy a secure website, you actually have to have your own IP address and set up everything manually and do everything else that goes with that. More importantly, we are lacking a technical feature today to specify for a domain name if it supports SSL at all. And more importantly, we don't have a way for a website to say that it wants to support only SSL. Because right now, even if you have sites that want to support 100% SSL,